The concept of the marginal rate of substitution captures the slope along the indifference curves. The marginal rate of substitution tells us the rate at which a consumer is willing to trade one good for the other. This gives us the slope at each point along the indifference curve. Since we see our indifference curves are bowed inward and downward sloping, we can see that the slope is not constant. It's going to depend on how much of each good is already consumed. And we see, as I have just mentioned, the more abundant the good, the more willing we are to trade. The less abundant the good, the less willing we are to trade. Now, let's talk about the consumer's optimal choice. When we have the optimal choice for the consumer, we are combining the budget constraint with the indifference curves or consumer preferences. The optimal point of consumption is going to be where we can reach the highest level of satisfaction given our income. So the optimal point of consumption is going to be the point where our budget constraint meets the highest indifference curve. Or in this example, it will be point A. So we have the highest level of satisfaction captured by the highest indifference curve that we can afford given our budget, the price of the goods as well as the income that we have. Another way that we can think about this is in terms of marginal utility and relative prices. So where the indifference curve is tangent to the budget constraint, this tells us that the slope of the indifference curve is equal to the slope of the budget constraint. Remember, the slope of the indifference curves is the marginal rate of substitution. And the slope of the budget constraint is the relative price of good X in terms of good Y. So, at the optimal point of consumption, the marginal rate of substitution, or the slope of the indifference curve, is equal to the relative price of good X in terms of good Y, or the slope of the budget constraint. Another way that we can think of the marginal rate of substitution is our relative satisfaction in consuming good X over our satisfaction in consuming good Y. The level of satisfaction can be captured by what we call marginal utility. And this is going to be the change in satisfaction from consuming one more unit of the good. So, since the marginal rate of substitution can be defined as marginal utility of good X over marginal utility of good Y, we can then transfer the optimal point of consumption so that the relative prices are equal to the marginal utilities. Using a little bit of simple algebra, we can see that the marginal utility that we have from consuming one more unit of good Y for each dollar that we spend on good Y is exactly equal to the marginal utility that we get from consuming good X and spending one more dollar on good X. So this tells us that at the optimum, the marginal utility per each dollar that we spend on good X is exactly equal to the marginal utility for each dollar that we spend on good Y. So the rate of satisfaction that we get from each dollar we spend on good X is exactly equal to the rate of satisfaction we get from each dollar that we spend on good Y. Now, when we start to see changes in our model, we need to talk about the income and the substitution effect. The income effect shows the change in consumption that results when there's a price change that moves a consumer along to a higher or lower indifference curve. The income and the substitution effect are going to occur when we have a change in the price of one of the goods. So for example, if the price of one good falls, the income effect tells us that people feel a little bit wealthier. They still have the same income, but that income goes a little bit farther because one of the goods feels cheaper. So therefore, they're going to get a higher level of satisfaction from the same money that they spend. They move to a higher indifference curve. Now, on the other hand, the substitution effect tells us that when there is a price change in one of the goods, the relative price has changed, and therefore we move along an existing indifference curve. So if the price of one good falls, that tells us that that good is relatively cheaper than it was before in terms of the other good. So we will consume more of the good whose price has fallen and less of the good that is now relatively more expensive. So let's say that the price of good X falls. Here we have good X and here we have good Y on the Y-axis. We start off at equilibrium point right here. Okay? And now we want to see what happens when the price of good X falls. If price of X falls, then good X is now cheaper, both in absolute terms as well as in relative terms, or in terms of good Y. So that tells us that we will have a biased shift out of the budget constraint. All else equal, at the maximum, we can consume more of good X. Now, with the substitution effect, with good X being cheaper than it was before, now good Y is relatively more expensive in terms of good X than it was before. In other words, to get one more unit of good Y, we need to give up more of good X than we did before. So this tells us that the substitution effect is going to move us from a point such as point A to a point such as point A prime along the existing indifference curve. We have a change in the marginal rate of substitution because we have a change in px over py. Okay. Now the income effect tells us, well, if good X is cheaper, our income goes a little bit farther. We feel wealthier overall. So we're going to move from indifference curve 1 to indifference curve 2. So from point A to point A prime. We can consume more of both goods. So now the reality, though, is that these two effects happen simultaneously. And which one dominates is going to tell us how much more or less of good Y we consume. So for sure, what we know is that when good X becomes cheaper, we definitely consume more of good X. But the income and substitution effect are going to tell us what happens with our consumption in good Y. So here, in reality, both the income and the substitution effect happen simultaneously. We move from a point such as point A to point B. So we're moving from point A to point B. When that happens, we see that definitely we are consuming more of good X. We'll call this XA and XB. But which of the effects dominates? Well, here is YA and here is YB. So what this tells us is that yes, we consume more of good X, but less of good Y. In that case, the substitution effect is dominating. Now, how can we determine the demand curve? Well, remember, the demand curve and the demand schedule gives us the quantity demanded for each price of the good. So what we can do here is look at what happens if the price of good X continues to fall. In this example, we're saying that good X is going to be apples and good Y is going to be oranges. So to determine the demand, we want to see by how much does good X change when the price of apples is changing. So we move from equilibrium point A to B to C. So here, what we are saying is that in budget constraint 1, the price of apples is $1.99. At $1.99, we consume 5 apples. At point B, we're saying that the price of apples is $1.49. And at that point, we're consuming 8 apples. At point C, the price of apples is 99 cents. And at 99 cents, we consume 10 apples. So we see that for this consumer, we're looking at the combination of their optimal consumption points between apples and oranges. We want to know what happens when the price of apples is changing. We see what happens when the price of apples is falling from $1.99 to 99 cents, and the corresponding change in the quantity demanded of apples. This combination gives us points A, B, and C that determine the demand for apples. So as you can see, the demand curve is directly related to the optimal consumption points that we derive when we look at the budget constraint and the indifference curves for a given consumer. So the demand curve is derived from the optimal consumption points for each consumer. Thank you so much for joining me in Module 3 on the theory of consumer choice and deriving the demand curve.